Now, to identify the domain and range given the graph of a piecewise function, this is what we gotta do. First, we have to remember that the domain is associated with the x variable and the range is associated with the y variable. So, to identify the domain of a function, we're gonna start looking at our graph from left to right. So, we're gonna start identifying where we have an existing graph, either piece. So, starting from minus infinity, the first moment I start having a graph is in -7. Because -7 is an included point, I have to put a bracket. Then if we continue, our first part stops in -2. Then I have a blank space between -2 and 1 where there is no graph at all. And then continuing from 1 all the way to 7, is where the other piece of our domain resides. Notice that because in -7 our function is a hollow point, the value is not included. Now, for the range, we start looking from down to up. So, looking from down to up, the first value of y for which I have a graph is in -6. Notice that -6 is a tip of my graph, so it is included. And if I continue, I keep having a graph, a sketch for these values of y. Notice that even though I have another graph here or another piece here, there's still a continuity in the values of y. And the last value of y for which I have a graph is in 6. So this is the domain for this graph, the range for this graph. Another example. Remember, to identify the domain, we're going to go from left to right. So notice that this function continues, carries on. So that means that this function has a domain starting from -infinity. So starting from -infinity, and my function stops in -3. And is included because I have a field point. Then I have a blank space between -3 and 0. So starting in 0, my function goes all the way to 6. So 6 is a not included value. Now, for the range, I'm going to start from bottom and go to the top. So, because this function continues all the way to infinity, that means that my range is going to start in -infinity. And then it's going to stop in -2. So my range goes from -infinity to -2. 2 is included. Then I have a blank space between -2 and 0, and then my graph continues from 0 to 5. 0 included, 5 not included. Last example. For these functions, first, domain. Starting from the -infinity, the first moment I see a graph is in -9, included. Then I carry on, and my graph stops existing in -2. Notice that -2 is not included. Then I have a blank space between -2 and 2. Continuing it in 2, I'm going to put it like this. And then my function, notice that this means that my function carries on all the way to infinity. That means that this domain is going to continue to infinity. Now for my range, I'm going to start bottom to top. So starting from the bottom, remember that this function goes all the way down. So this means that my range is going to start from -infinity. So starting from -infinity, for all these values, there's a piece of graph that exists. For all these values, there is a piece of graph that exists. For all these values, even though this function has finished, there's another piece existing here. So for all these values, all up until 6.1, 6.2, the values in my range are existing, okay? So it doesn't matter if the ranges of the two pieces overlap. We are talking about the big picture, o sea, the range of the entire piecewise function. And that's it.